It's your boy, and we are back at it again with another maths video. In today's video, we're going to be looking at an example of how to find the equation of a normal line which is passing through a point on a curve. Please, if you have not watched the video where I show you how to find the equation of a tangent, it would be a better idea if you watch that video first before you watch this video. So anyway, in today's video lesson, I have the curve. This is the example curve that I have here, and the question is, what is the equation of the normal line that passes through the point 1, 0 on the curve? What is the equation of the normal that passes through the point 1, 0 on the curve? So the first thing to realize is that a normal is a straight line, and every straight line is expressed in the form of, that is the general equation of a straight line, where x1, y1 is literally any point that we pick that is passing on the normal line. As we can see here, 1, 0 is a point on the normal line, because the question is, the normal line is passing through the point 1, 0. So straight away we can plug in the coordinates and say y minus 0 is equal to m multiplied by x minus 1. Because the x coordinate is 1, the y coordinate is 0. Simplifying this is going to give us, and our duty now is to find the gradient m. Well, how do you find the gradient of a normal line? You know that a normal line is perpendicular to the tangent. If you haven't watched my video where I explain what a normal is, it's a good idea for you to watch that video first. As I explained before, the normal is a straight line that is drawn perpendicular to the tangent of a point. So in this case, if we have the point 1, 0, if we draw a tangent on that point 1, 0, the normal is therefore the line that passes through that point and is perpendicular to the tangent. And we know that whenever two lines are perpendicular, the product of the gradients is equal to -1. In other words, m1 multiplied by m2 is equal to -1, where m1 is the gradient of one line and m2 is the gradient of the other line. So if we want to find the gradient of the normal, then it makes sense for us to find the gradient of the tangent. And if you want to find the gradient of the tangent, you differentiate. If you don't know any of this, watch my previous videos in the playlist first before continuing with this video. Everything will make sense, I promise. So we have our y is equal to 4x to the power 4, da 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 da. If we differentiate this, and our derivative when x is equal to 1 is equal to 4. So in other words, the gradient of the tangent is equal to 4, so we can say that our m1 is equal to 4. So in other words, since m1, m2 is equal to -1, then we know that 4 multiplied by m2 is equal to -1. So m2, which is the gradient of the normal, m2 is equal to -1/4, and this is equal to the gradient, this is equal to the gradient of the normal. This is the gradient of the normal. So the gradient of the normal is going to be equal to -1/4. Remember, this relationship is when two lines are perpendicular, and we know that the normal is perpendicular to the tangent. So in other words, since we know that the equation of the normal is y is equal to m multiplied by x minus 1, then our y is equal to -1/4 multiplied by x minus 1. And that's the equation of our normal. And when we simplify this, we are going to get y is equal to -1/4x plus 1/4. And this is going to be the equation of our normal line. Just to confirm it here, I have Desmos.com, so this is my curve here. Let me just zoom that in. This is my curve, and then the tangent at the point 1, 0 is y is equal to 4x minus 4. That's the tangent, and our normal line, we've deduced it to be -0.25x plus 0.25. And as you can see, the green line is our normal, It's passing through the point 1 comma 0, and as you can see, it's perpendicular to the blue line, which is the tangent. So that's the equation of our normal, which is the green line. So it's passing through the point 1 comma 0, it's perpendicular to the tangent, which is the blue line. So that's our normal. Anyway, that brings us to the end of the video on finding the equation of a normal. If you enjoyed the video, smash that like button, subscribe to the channel, press the notification bell so that you can be notified every time I post a video. Share the video, share news about the channel, and until next time, take care.